Hi. In this session, we'll be discussing an interesting algorithm to find an Euler circuit or a universal line in a graph. Okay, so it's called a Fleury's algorithm. So before that, what is an Euler circuit? Okay, an Euler circuit is basically a closed fork which contains all the edges of the graph exactly once. Okay, and what is a universal line? Or it is also called by another name as Euler path. So we'll be using these two terminologies interchangeably. So what is an Euler path? An Euler path is an open walk which contains all the edges of the graph exactly once. Okay, it's an open walk, but in the case of Euler circuit, it's a closed walk. Okay, so these terms are actually used interchangeably in many textbooks. So you just think that Euler circuit is actually our Euler line which you have studied. So Euler line is now we'll be calling it as Euler circuit. Okay, so you have to be mindful of the terminology here. And for your universal line which you have studied earlier, now we will be calling it as Euler path. Okay, so I know that you have studied path and circuit in different terminologies, but just remember that Euler circuit for our purpose now, it is basically a closed walk which contains all the edges of the graph exactly once, and an Euler path for our purpose is basically an open walk which contains all the edges of the graph exactly once. Okay, and we have also studied some characterizations of this Euler lines. Okay, what are they? And a graph is Eulerian if and only if all the vertices have even degree. Okay, so that is one characterization which you have studied. And similarly for a universal line or Euler path also we have studied that. What is it? A graph has a universal line or a Euler path if and only if there are exactly two vertices of there are only two vertices of even degree. Okay, so a graph will have an Euler path or a universal line if and only if there are exactly two vertices of odd degree. So when you are given a problem to find a Euler line or a Euler path, first you have to check whether these conditions are satisfied. So in order to find an Euler circuit, all the vertices should have even degree, and in order to find an Euler path or a universal line, all the vertices should have even degree except two, exactly two. Okay, so that's the idea. Okay, now what is this algorithm? How will you choose this algorithm? What it will do? So basically this algorithm is a systematic way to find an Euler line or a universal line. This QS systematic way is given to you. Okay, and so in many cases you can always guess the Euler line, but if the graph is very complex, it will be difficult. So if you follow this systematic method or algorithm, you can easily find out how to find a universal line or a Euler line. Okay, so what's the method? So the basic idea of this algorithm is that you should not burn your bridges. So what do you mean by burn your bridges? Don't, basically the idea is don't use bridges in the first instance. Don't use bridges wherever possible. Okay, only if there are no other choices left, you should use bridge. So before that, what's a bridge? So bridge is nothing, basically bridge is nothing but it's an edge only, but it has a very interesting property that once you delete that bridge from your graph, the graph would be disconnected. Okay, for example, if you look at this graph here, if I delete this edge, what will happen? This graph would be disconnected. Okay, but if I delete some other edge, suppose I am deleting this edge here. Okay, suppose I am deleting that edge here, will the graph be disconnected? No. Okay, so but if you delete this edge, what happens is that the graph will be disconnected, but if I delete some other edge, the graph will not be disconnected. So okay, so that is a bridge is basically an edge whose deletion from the graph disconnects the graph. Okay, so why? So that's the idea. So why should you not include bridges in the first instance in an Euler graph? When you construct an Euler circuit, why is it so? So if you think closely, suppose I want to construct an Euler circuit starting from this edge. Suppose I want to construct an Euler circuit starting from this vertex. Okay, now what will happen is that if I, of course this graph will not have an Euler circuit because it has odd degree, but just think for a second now. So if I use this edge now, okay, what will happen? So if I use this edge and comes to this side, I cannot go back to the previous edges. That's the issue. Okay, so if I use this edge in the first instance, so once I pass through this edge, I cannot go back to the edges in this portion now. Okay, so that is why you don't use bridges in the first instance. Okay, so if you use the edge in the first instance, still the problem is that once you cross over this edge to this side, you can't return back to this side without repeating this edge again. So you use bridges only in the last instance. In the first instance, you never use bridges. That's the central idea of this algorithm. Okay, and this particular graph will not contain an Euler circuit, but it will contain an Euler path because there are only two vertices of odd degree, all other vertices are of even degree. Okay, so even when you construct an Euler path or a unicursal line, even if, when you construct that, don't use that these bridges in the first. When you, even if you construct an Euler path also, so this will contain an Euler path because there are exactly two vertices of odd degree, all other vertices are of even degree. So even when you construct an Euler path, suppose you are starting with A here and B here, don't use this edge in the first instance. First you go through other edges only. Only when those edges are used up, you can use this edge AB. Because if you, first of all, if you use this edge AB, you can't come back to cover all other edges. So the central idea of this algorithm is don't use bridges in the first instance, or simply don't burn your bridges. Okay, and this graph is, you can see the shaded edges are actually bridges also. You can just check it out. I have shaded some edges. Those edges are the property that there are bridges. For example, if I delete this edge, this graph will be disconnected. You will have a bigger graph and a small self loop would be there. Okay, and if I delete this edge also, this will be disconnected. You will have a bigger graph and also an edge, a self loop with a single edge there. And similarly, this edge is also a bridge. If I delete this edge, you will be obtaining a small portion and a bigger graph. Okay, so this shaded edges are actually bridges there. Okay, and what is the algorithm basically? Okay, the algorithm is that, you have to remember two things. Suppose you need to find an Euler circuit, or basically you have to find an Euler line which you have studied. Okay, if you need an Euler line, you know that all the vertex has even degree, then you can start at any vertex you like. Okay, so the starting point is any vertex you can, suppose your starting point is V0, you start at V0. Okay, so if you can start at any vertex you like. Okay, but in the case of an Euler path or a unicursal line, okay, you know that there are exactly two vertices of odd degree, so you have to start at the vertex which is of odd degree. There are two choices for you. Suppose you have two vertexes, suppose V0 and V1 are of odd degree, you can choose anyone you like. Okay, but you have to start at an odd vertex only in the case of unicursal line or an Euler path. Okay, suppose I am starting at V1, I will be getting an Euler circuit. Suppose I am starting at V0, I will be getting a different Euler circuit or a different Euler path. Okay, it doesn't matter. Okay, there can be many Euler circuits and many Euler paths in the same graph. Okay, so your Euler path and circuit depends upon your starting point. So if you start with a different vertex, you will be getting a different path. Okay, so that's no issue is there. Okay, so if you want an Euler circuit, you can start at any vertex you like. If you want an Euler path, you should start at only the odd vertex. There are two odd vertex, you can choose any one of you like. Okay, so that is the basic idea. Okay, now from V0, you can suppose in both cases, suppose you had obtained a starting vertex. Okay, now suppose V0 is adjacent to V1, V2, V3. Okay, so either you can go to the next vertex as V0, V1, or V0, V2, or V0, V3. Okay, you can either start from V0, I can go to V1, or I can start from V0, I can go to V2, or I can start from V0, I can go to V3. But the next vertex should be chosen in such a way that this V0, V1 is not a bridge. Okay, so the next vertex should be chosen in such a way that this V0, V1 is not a bridge. Okay, suppose V0, V2 is a bridge, you will not choose this way. Suppose V0, V3 is not a bridge, you can choose V0, V3. Okay, so that is the next idea. So from the starting vertex, the next vertex is chosen in such a way that this edge will not be a bridge. Okay, if there are no such edges, suppose your edges, there is only one bridge left there and no more edges are there, then you can choose that bridge and the last instance only. Okay, so once you have a starting vertex, the next vertex is chosen in such a way that that edge is not a bridge. Okay, now the next step is that you will just delete this chosen edge from the graph so that you will not repeat this edge again. Okay, so once you have chosen that edge, you will, in the right hand side, you will write down the Euler path. Like suppose in the first way your Euler path is now at V0, the next one it is V0, V1. So you will just keep track of the edges there and you will delete those edges from the graph so that these edges are not again repeated in our traversal of the graph. Okay, now once you delete this graph, this edge, you are now at the point V1. Now this at the point V1, you may have some other edges will be there. Suppose there is V3 going from V3 V1, and suppose there is an edge going to V4 from V1. So you can choose either V3 V1 V3 or V1 V4 in such a way that it is not a bridge. Okay, we will see an example so that you will understand this concept better. So this is the basic idea. Okay, so there are two principles. So this is the algorithm written here. They can ask you write down the Fleury's algorithm. So you can start at any vertex and you can traverse the edges in an arbitrary manner, subject to two conditions. At each step, use a bridge only if there is no other choice. That is the one condition. And next condition is that erase the edges as they are traversed. Also, you have to keep track of the edges. Okay. So in a you can keep track of the edges in the right hand side, but erase the edges once they are chosen. So these are the two ideas which we will be using to find an Euler circuit. Now let us look at the example now. Okay, suppose I am giving you a graph here. Okay, and suppose you have to find an Euler path here. Suppose you need to find a universal line here. You want to find a universal line here. So you know that in order to have an universal line, the graph should have exactly two vertices of 4 degrees. So let us first check. So suppose the vertex of this has degree 2, this has degree 4, 2, this has degree 3. So there is one vertex of degree odd degree and there is another vertex of odd degree. So there are exactly two vertices of odd degree which are F and D. So you should start from any of these vertex. Okay, suppose I am starting with F. So you start with any of the vertex. Suppose I am starting with F. So this is my starting vertex F. Okay, now from F where can I go? I can go to either G, or from F I can go to E, or from F I can go to A. So these three possibilities are there. So from F, now I am at F. So from F I have three possibilities. I can either go to G, or I can either go to E, and I can either go to A, and you can see that none of these edges are bridges. So your choice. Okay, suppose I am taking A. So I will write down. So in the first step my edge, my Euler path first was at F. In the second step now it is at FA now. So I have chosen this edge now. The next idea is I will just delete this edge now from the graph. Okay, I will just delete this edge from the graph. Now my Euler path is at A now. So that is the point now. Okay, so once you have chosen this edge, write down somewhere as FA and then delete that edge. Okay, now from A, which all choices do I have? From A, I can either go to B, or I can either go to C, or I can either go to D. Three choices are there. But if you see here, I can't choose this edge AD because it is a bridge. Because once I delete that edge, it will become a disconnected. So I can't choose this edge AD there. So only two possibilities for me, either B or you C. It is your choice. Suppose I am choosing this B. What will I do? I'll write it down and then I'll delete that edge here. Okay, now my Euler path is at the vertex P. I hope it is clear. So you start from any vertex F, any odd vertex. In the Euler circuit, you can start from any vertex because all the vertices would be of equal degree. For the Euler path, you have to start from an odd vertex. So now I started from F, and from F I had three choices. I chose A, that edge. I wrote it here, and then I deleted the edge. Okay, now I am at A. I have three choices FB, FC, FD. I have to choose an edge in such a way that it is not a bridge. Okay, but I can see that AD is a bridge, so I cannot choose AD. So I either choose FB or FC. So I just chosen B. You can also choose C. You will be getting a different circuit. It's your choice. Okay, so I choose this B. Okay, now I am at B. So I'll delete this edge AB. Okay, so from B you have, let's look at the graph now. So now this is the idea. I have chosen A. I deleted that edge FA. You can see this. Again I chose the edge B. So I deleted that edge B. Now you are at B. Now you have how many choices are there? You can have three choices. You have BC is there. You can go to BG. You can go to BE also. Three choices are there. But if you see here, if I choose this BC, BC is a bridge. If you choose that, it will disconnect the graph. So don't choose BC. So either you can go to BG or you can go to BE. Suppose I am taking this BE. Okay, I am choosing this edge BE. So what is the next step? You write it down somewhere. Then you have to delete that edge BE. So next step you will just delete that edge BE. Now you are at the vertex E now. Okay. So now next step I am going to delete this edge B. Now I am at the vertex E now. Now the Euler path is now FAB. It is written here. It is written here. Okay. And from E there are no more choices. Only one edge is left. It is a bridge, but we have no other edges. So we have no other way but to choose this edge again F. Okay. Even though this is a bridge, there are no other choices for us. No other edges for us from it go from E. So only one edge is there. So we have to choose this bridge. Okay. There is no other choice. So I'll choose this F. Now I am at F. I'll just delete this edge F now, edge EF now. Okay, and from F again there is only one choice, no other choice left. So I will have to choose this edge G. Okay, once I am at G now, no other choice left for me. Even though it's a bridge, we will be taking this edge B and deleting it from the graph. Okay, so these are the idea. So we are now at B. We have no other choice. So now our path is now F A B E F G B. It is written here. We have kept track of it. At B also no other choice, only one choice, that is C. Okay, once you have reached C, delete this edge. No other choice again, only A here. Okay, because no other edges are coming out from here, so you have reached A. Okay, no other choice there. Still there is only one edge left from A to D, so D is there. So once you have reached the point D, like this, but now you have reached the point here, and this is your the oil path now. There are no more edges left, or there are no more neighbors of D. No more edges are left, or no more neighbors of D are left. So that is the end of the algorithm. So we'll stop here. So now you have obtained the path as FAB EFGBCAD using this idea. You could also obtain a different path if you are started from some other vertex, for example here D, but this is the path which I got from I started from this vertex. So this is the path now. Now let us check whether it's an Euler path. So let us look at this graph now. What is it? This is the path which we have obtained, FABEFGBCAD. Let us check it. So you started with F, you went through A, reached here, you went through B, you reached here, you went through E, you reached here, now you went through F, you reached here. Okay, now here you are going to G, from G you are going to B, and from B you are going to C, and from C I am going to A, and from A I am going to D. Okay, so you just check it out. So this path actually covers all the edges exactly once, and this is your Euler path. Okay, I hope it is clear. So you can start for an Euler circuit, you can start from any vertex, and from the next vertex is chosen in such a way that that edge is not a bridge. Okay, if there are no such edges, you have to choose a bridge. There is no other way. Okay, so try to avoid bridges as far as possible. Only if there are no edges, you will choose a bridge. Okay, and once an edge is chosen, delete it from the graph. Okay, so that there will be no confusion for you. So also you have to jot down which edge you have chosen somewhere. Okay, and when you come to the next vertex again, take an edge which is not a bridge. Okay, jot it down somewhere and delete it from the graph and proceed until there are no edges left. So this is Fleury's algorithm. Okay, so that's very simple thing only. And I have given an algorithm in another form also, which will help you to program this algorithm. It is not required for examination, but they can ask you what's the algorithm. You can use any of the algorithm which I given you. Essentially the idea is just the same. Okay, so just go through this and try to understand this again, and let us look at one more example here. Okay, so using Fleury's algorithm, construct an Euler circuit in the following graph. Okay, so here also first check out whether there can be an Euler circuit by looking at the degrees, and if you look at the degrees, you can see that every vertex has even degree, and therefore an Euler circuit is possible. Okay, and you can start from any of the vertex. So if you want to start from C, you can start from C. Only thing is that the next edges should be chosen in such a way that it is not a bridge. Okay, you can start from any vertex. So if you want to start at A, you can start at A. Okay, from A you can choose any vertex you like. Okay, except that it is not a bridge. Okay, so in that we can start. So one way to do is that you can take a worksheet or right hand side, and you can successively choose for some vertex and delete and see it. And I'll now show you a way to write it in a condensed form, so that in your examination it will be easy to do this problem in a fixed page. Okay, there's no need to make it bigger here. So what you'll do is that I'll make a table like this. Okay, this table will have 3 columns. It's your choice. First column will be my path, the status of my path. The second column will be the next edge which I am going to choose, and if I have any remarks or reasoning, I'll take. Okay, so the first column, suppose I'm denoting my path by the symbol pi. Okay, so that's why it is written here. So suppose I'm starting with A. So my starting vertex is A here. We can here, and A have 3 choices are there. How many choices for A are for the next vertex are there? I can go from A to either G, I can go from A to either B or C or D. Okay, none of these edges is a bridge. So suppose I am choosing as B. So suppose I am going from the next vertex as B. Then so in your working column, you can just delete this edge B and see what is there. So suppose I am taking next vertex as B. I'll write it as like here. My next edge is AB. Okay, so now the path is at AB now, and from B now. And once you have reached B, there is no other choice, only one edge is there, so you have to choose this edge mandatorily because no other edges are there. So you'll choose this BC, so you'll write as BC. and you can write it as only one edge from B remains. Okay, now you are at A, B, C, and now you are at C. Okay, and from C, what all choices are there? From C, I can either go to E, or I can come to A, or I can go to D. None of them are bridges. So suppose I am going to A, I'll write as from C, A. So now I just from C is a bridge, choose anyone. So I'll just keep track of all the records in a table here. Okay, so from A, again you can choose other edges. Like that you can complete this table. If you want, you can use this method also, or you can use the direct method also, where you will be drawing the graph, but it will be a lengthy one. That is why I told you this one is also sufficient. If you want, you can condense all the steps in this graph also. Okay, and also remember, if you start from a different starting point, you may get a different oil circuit. It's no issue. Only thing is that you should ultimately get a circuit which contains all the edges exactly once and comes back at the starting point without repeating. Okay, for the Euler circuit, and for Euler line, it can be it should be an open walk, so the edges should not repeat but should cover all the edges. That's the only idea there. Okay, and I'll have also included 2 homeworks for you. You can try this. You can start from any of the vertex. You need to find Euler circuits or Euler lines here. Okay, you can start from any of the vertex here. Okay, you can go through any of the vertex and choose the next edge in such a way that it is not a bridge, and if you can draw it or you can use it in a table form, please try to do this problem. It's very simple. Please try it so that it's better understood. Okay, so we'll stop here. Thank you.